everyone, this is Liu Shiji, and I'm now a current master student in University of Washington. In the following video, I'm going to introduce the process of daylight analysis. The virtual model is created within the Revit environment and then imported into Rhino in order to use the analysis tool of DIVA. For the very first part, which is the basic information of myself. My name is Liu Shiji, and I've earned my bachelor degree in National Cheng Kung University with the major of civil engineering and the 2 minors of architecture as well as urban planning. After that, I have joined the University of California in Berkeley for the master study of architecture. And then I have transferred to the University of Washington in Seattle for the master study of construction engineering. In the city of Seattle, I've earned my LEED GA as well as the BIM certificate. I further passed the Revit Professional Certificate as well. And for the computing skills, as a former architecture student, I do know how to use the programs within the Adobe series. And as a current master student of construction engineering/management, I do know how to manipulate all the building information modeling tools. And of course, the Windows Office series as well. And for the second part, I would like to introduce our design project of fire station in the Bethel neighborhood. The building is composed by the 3 programs as apparatus bay, an administration area, and the crew area. The program of Revit is adopted for the entire design process. As you can see, we have generated 2 design options, and we have adopted the first one to continue the study. We have completed all the architecture drawings within the Revit program, which includes site plans, level 1, 2, and roof plans. We have further done the color coding for the plans in order to show the 3 major programs in detail. And of course, the elevation as well as the section are drawn. We have also completed the wall sections for the 3 major programs. And we have also drew the interior elevations as well as the interior rendering for the better communication with the users as well as the publics. We have further created our own families within the programs, such as door, gutter, and the furnitures. And in the following sections, I'm going to demonstrate the daylighting analysis step by step. In the very end of the presentation, I'm going to show you guys all the analysis results before and after the redesign in order to compare their daylighting performances. Okay, so now we're in the Revit working environment. As you can see, this is our design project of the fire station in Bethel neighborhood. And this part is the apparatus bay, and this part is the administration area. And the second story building is the crew area. And we also got an existing building located in the north side of the design project. In order to process the daylighting analysis, the very first things that we have to do is to simplify the model. The reason for us to do that is because, as we all know, that the Revit programs is able to create the building component into very detail. However, the detailed model that being imported into Rhinoceros will dramatically increase the required time for the process of daylighting analysis. In order to streamline the analysis process, we must either delete or turn off the visibility of the building components. The unwanted building components are those will only give very little effects to the daylighting performances. We can either go into the feasibility and graphic by typing VV or VG and uncheck the unwanted categories such as areas, mass, and maybe parking and so on. However, I will use a second approach, which is more straightforward. I will just directly delete the unwanted components such as the car, the parking space, the fence, the bench, and so on. Remember, the deleted components are those will only give very little or even have no effect to the daylighting performances. Okay, so now you're seeing the simplified model. As you can see, I have deleted all the unnecessary building components. However, I choose to keep the existing building as well as all the trees. The reason is that those components do have effects to the design project with the aspect of daylighting performances. They do catch shadow as well as block the sunlight. Once we got the desirable Revit model, we're going to export it. So the format that we're going to use is the CAD format of DWG. And please remember that by exporting DWG file, we must within the 3D view. And we're going to click the setup button, and in the layer tabs we can understand that these are the categories for the Revit model, and these are the layer name for the DWG file, and they are related. I would like to scroll down and to find the window category. By clicking the plus sign, we will find out that there are some building components within the window category, such as wing, frame, mullion, glass, and so on. And I would like to rename the glass component as a glass window. The reason for that is that I want to isolate the glass component for the further manipulation. This is very important while implementing the daylighting analysis, and I will talk about it later. And we're going to the solid and choose ACIS solids as the type of the exported file. And we also want to make sure the unit remains inch or foot. After all the settings, we're good to go. By clicking next, and we're going to save our DWG file wherever you want. I'm going to use the file name as Revit to DWG, and I will choose to use the latest version of AutoCAD, which is 2013. By clicking OK and a couple seconds of waiting, we will have our own DWG file. And we will further use that DWG file to import into the Rhinoceros working environment and use the analysis tool of DIVA. Okay, so now we're in the Rhino working environment. The very first things that I have to make sure is the unit. In File, Properties, and Units, we're going to change the model units from millimeters to inches and clicking OK. And now we're good to go. We're going to import the DWG file by clicking Import and choose the Revit to DWG file, clicking Open. And we remain all the default settings, but we have still to change the layout units from millimeters to inches, and clicking OK. The import process can take seconds to minutes. It depends on your complexity of the model. And this also indicates the importance of the simplicity of the model. We only want to import all the necessary components rather than the model into very details. And by clicking Perspective tab, we're going to the Perspective mode. And as you can see, we successfully import the Revit model into Rhino working environment. However, I would say the topography is still very complex, and we don't need that many of details for the existing building. So I will recommend to simplify the topography and change it into some surface. We can also change the existing building to a giant box. And we got the fire truck here. We can also replace it with the box shape. We only need the geometry rather than all the details while implementing the daylighting analysis. And if we click the layers, and we'll find out that all the layers in Rhino are the same as the layers in the DWG file. And the layers in DWG file are related to the categories in Revit. For now, I would like to point out another very important issue. I'm going to isolate the glass by turning off the visibility of other layers. Well, okay. So there are the windows. And we're going to explode them into surfaces. Okay, now we have it. And we turn off the frame. That is the glass itself. If you go closer, you'll find out that the glass panel is a box rather than one surface, and that will make a really big issue while doing the daylighting analysis, because the daylight will reflect multiple times within this glass and increase the simulation required time dramatically. In order to avoid this issue, we're going to explore all the glass boxes once again. And we have to, unfortunately, clean the boxes one by one by deleting the 5 unwanted surface, and to remain the glass as one surface rather than a box. We're going to do it one by one, surface by surface, to make sure this won't cut us during the simulation. It's a rather tedious process, but it is very important. And we have to do the process for each windows, as well as the curtain wall here. In order to streamline the tedious process of converting the box-shaped glass into one piece of surface, we can go to the website of DIVA for Rhino to download the scripts for converting geometry. And under the Revit models category, we can find out the script we want, and we can click it to download it. After that, we go back to our Rhino working environment and type the command of load script, and to add the wanted script into our project. And we click on it and we can load it. The warning says that the glass has to be exploded in advance to implementing the script. And if we have done it, we click yes to continue. However, I have to confess that for my own experience, the script is not as powerful as I expect. So eventually, I clean up all the windows by my own hand. But I will still provide you the alternative way for your own practice. Okay, so now you're looking at the simplified version of our design model. As you can see, I have drew the topography with 3 surfaces only, and had also replaced the administration area as well as the crew area with the 2 simple geometries. The reason for me to do that is because for the daylighting analysis, I will only focus on the apparatus bay. And I have also replaced the existing building with a huge box. If we take a close look, let me turn off the visibility of the roof. You'll find out that I have also replaced the fire trucks with 2 simple boxes. Once we have the correct simplified version of the model, we're good to go. Of course, we have to have DIVA installed in the Rhino. Fortunately, DIVA is free for us students. And the first thing is to assign the location by clicking the location button. Since the design project locates in the Bothell neighborhood, I'm going to pick Seattle, Tacoma. And as you can see, DIVA automatically generates the layers for the simulation. And then we're going to determine the analysis boundary. With the plan drawing, I have already drew the analysis boundary with the purple color. I will only focus on the apparatus bay, the corridor, the clean room, as well as the bunker. I will not take the storages into consideration while implementing the analysis, because those spaces are not very important with the aspect of daylighting. And I'm going to mention that I have reorganized the layers and renamed the layers for your better understanding. And the daylighting analysis is a grid-based simulation. The nuts, which is the grid, has to be placed in order to implement the simulation. In order to do that, I have already drew the plan for placing the grid. I drew the plan with the tools of polyline and the surface from planar curves. Let me turn off the roof, the floor, as well as the building pad, and turn off the grid base for your understanding. As you can see, the grid base is exactly the same as the analysis boundary. And one thing that I have to mention is that we have to check the direction of the grid plane. I'm going to click and select the plane and type the command of dir. And we will find out that the direction of the face is toward the downside. And we have to change the direction by clicking flip. Okay, it seems good to me for now. And we'll press enter. And after all the settings, I'm going to press the nuts by clicking the button of nuts. And DIVA will ask me to pick one or more planar surfaces to place the nuts. So I'm going to click and select the grid plane and press enter. I'm asking to enter the distance of sample nuts of our analysis surface. And I'm going to type 40 inches, which is the distance between the floor and the table surface, the working surface. Press enter again, and I'm asking to enter the distance between the two nuts. I'm going to type 15 for this practice. Enter. And it seems pretty good. The grid systems are generated based on the grid plane. With all the grids, we're now going to implement the daylighting analysis. Okay, for now we got our own grid systems. And the next things we're going to do is to assign the materials. We're going to click on the materials button and assign materials. As you can see, DIVA allows us to assign the materials to the Rhino layers. And the Rhino layers is basically are related to the categories in Revit. So we'll basically assign the materials to the Revit categories as building pad, curtain glass, curtain mullions, and so on. After assigning the materials, we're going to submit the material information. And then we're going to click on the metric button. The first analysis we're going to implement is the illuminance analysis. Illuminance means the amount of sunlight received directly from the sun itself rather than reflection. So we're going to choose daylight grid-based point in time illuminance. The metric, of course, is illuminance. And I will set the sky condition as well as the date and time with the scenario of clear sky with sun and June 21 at noon, which is 12 o'clock. I'm going to mention that I recommend to play with the illuminance analysis with 3 different scenarios. The first one is going to be June 21 at noon with the clear sky, which is the condition the building received the largest amount of sunlight. The second one will be December 21st at noon with clear sky, which is the condition that the sun angles becomes the smallest and the glare happens very easily. And the last scenario is December 21st with the overcast sky. With this condition, the building will receive the least amount of daylight. And after all the settings, I'm going to click on the button of Run Simulation. And the window will pop out. We have to wait for minutes to hours, depends on the complexity of our design model. Okay, after the waiting, now we got into the DIVA metric dialog in order to set up the layout. For the minimum illuminance, I'm setting in as the value of 300 lux and 2000 for the maximum illuminance value. The boundary is the desirable range for the illuminance for the typical working spaces. And I have also set the color sync for the second one and check level 1 peak knots, level 0 knots, as well as color extreme values. We can retrieve our simulation results by clicking the button. And the results might take a few seconds to pop out. It still depends on your complexity of the model. And after we got the results, let us go back to the top view. The color legend shows the illuminance value from 300 to 2000, which is within the desirable range. And for the spaces which are underlit, the color of black is adopted. And the color of pink is used for the spaces which are overlit. And we can also take a look about the mean value, which is 823 lux, within the condition of clear sky, June 21st at noon. And there are 49.2% of the area is between the desirable range. And there are 13.5% of the area is overlit, and 33.3% of the area is underlit. And we can further go closer and take a look about the grid system. Let me turn off the roof to show that each grid has its own illuminance values. So we can take a snapshot for this image as well as for the values of the data to record our simulation results. If we want to rerun the simulation, we would like to turn on the roof component once again and left click the metric button in order to change the scenario. We can change the sky condition as well as the date and time, and to rerun the simulation by clicking this button. And we can also retrieve the previous simulation result by right-click the metrics. And we'd like to retrieve the illuminance value by selecting the illuminance values and load selected metrics. We'd like to go back to the illuminance, the grid-based analysis, and choose the scenario which is wanted. Okay, with the help of DIVA, we can actually implement more daylighting analysis in addition to illuminance, such as useful daylight illuminance, UDI, as well as luminance. However, I decided to put more emphasis on the redesign within the Revit environment, and I will only mention the final analysis results in the following section of conclusion. Alright, let's go back to the Revit. Based on the analysis results of illuminance, I decided to add the skylight to bring in the sunlight to the interior spaces. In order to get our skylight component, I'm going to click on the Insert tab, Lot Family. I'm going to go to the Library, US Interior, and find the windows to get our skylight. We can further by clicking Edit Type, Duplicate, and changing the dimensions in order to get different type of skylight. For example, I got two different types of skylight in the design project. One is the square one and another is the rectangular one. And we have to further use the Shape tool in the Architecture tab in order to puncture the hole to bring in the daylight. And I have further add the exterior sun shading devices in order to block the sunlight for the spaces nearby the huge curtain wall. And we'll see the difference between the before and after the redesign. And after the revision, we can redo all the process. We can export the Revit file as the DWG file format and import that file into Rhino and rerun the DIVA for the daylighting simulation. Okay, in the very last section, I would like to conclude with the comparison between the daylighting performances before and after the redesign. I would like to re-mention that the redesign includes the skylight for the interior spaces, as well as the shading devices for the exterior. With the aspect of illuminance, the upper row shows the daylighting performances for the original design, and the lower row shows the performances for the redesign. One can easily understand that in the day of summer solstice, the spaces nearby the curtain wall are overlit. On the other hand, in the day of winter solstice, which is the day having the least amount of sunlight, the interior spaces are way too dark. And after the revision, one can easily understand that the spaces nearby the curtain wall become more comfortable, and the interior spaces become lighter as well, being desirable for our human being. And with the aspect of useful daylight illuminance, for the original design, we only got 34% of the time throughout a year are within the desirable range, which is unacceptable. In contrast, after the redesign, we got 61% within a year within the desirable range. The increased number indicates the redesign is very successful. With the aspect of luminance, we can have the render figure, and then we can convert those images into full color. And one can easily realize that the originally way too dark spaces become brighter due to the added skylight, and the originally overlit spaces become more desirable because of the extra shading device. Okay, based on those daylighting analysis results, I believe we can conclude that the redesign strategies are very useful, and also shows the analysis tool is very powerful while designing the building. I hope you guys all enjoy the video, and thank you very much for your attention. I appreciate it.